Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new topic regarding the force on the flat vertical plate moving in the direction of jet. So we need to find out the force exerted by the jet on a flat vertical plate which is in moving conditions. So up to now we have discussed regarding the stationary condition of these different kind of plates. Now we'll see when the plate is moving, then how to identify the force exerted by the jet. We need to find out the force on a flat vertical plate which is moving condition in the direction of jet. So this is the diagram which I have taken from the book. You can see. So here if you see here, this is the jet of the fluid which is moving, and suppose like if you draw the diagram in this way, this is the pipe is there, and from this pipe a nozzle is connected to this, and the jet of fluid which is coming out from this nozzle is this way. Okay, and this one I can say this is a pipe through which the water is flowing or the fluid is flowing, and this is the nozzle part. This is the nozzle, and this one the jet of fluid. This is the jet of fluid which is flowing through this, flowing from the nozzle, and this is the plate. This is the plate. Now the plate is in moving condition, not in the stationary condition. Up to now we have seen the plate was in stationary condition. Now we'll see after striking the jet of this fluid, the plate started moving. So here we'll consider a few parameters which is related to this. First of all, we need to consider that there is a jet which is striking this plate with a velocity of v. Okay, and after striking, the jet started moving. You can see this is the v is there, and this is u. That means this is the movement of the plate. Actually, the plate after striking the jet on this plate, the plate started moving with a velocity of small u. Here capital V, this is small u. So let's write down some parameters are there as I told you. First one is v. So v is nothing but velocity of the jet. This is velocity of the jet, which we know that we can define, or we can denote this unit in this one, meter per second. Similarly, small u is the velocity of the plate. Velocity of the plate or velocity of the flat plate we can write. So here also the unit will be meter per second. And the jet which is coming out from this nozzle, okay, so there will be a diameter of this jet will be there, that is d. So this is dia of the jet, and this unit will be meter. And similarly, as diameter is given, so area we can calculate. This is actually the area of the cross section. So this one we can write the cross section area. This is actually we can write cross section area of the jet. This one we need to write in terms of meter square unit, because this formula actually this is pi by 4 d square. So meter square it will come. And these are the parameters are there which we need to consider for this. Now actually in this case, what we need to consider, what we need to assumption, that the jet, actually the jet of the fluid is not striking to this plate, because you can see after striking the jet of this fluid to this plate, the plate started moving. So the jet also moving. You can see here the jet of the fluid is also moving with the velocity v, and the plate after striking the jet to the plate also started moving. So this also moving. You can see this is the movement after moving this one. So this is the new formations. This is the new formations of this plate. We can see here. This is the plate is there. Okay, and the fluid which is like you can see the fluid also will be in this direction, and finally the fluid will be goes out from this, and this is the plate is there. Okay, so this much distance traveled from here to here, this much distance traveled by the plate with the impact of the jet. So what we need to find out? We need to find out the force exerted by the jet on the flat plate which is in moving conditions, okay, which is not stationary. Okay, this much distance traveled, we can say x distance traveled here. Now what about this velocity? So here actually these two velocity what I have shown you, v and u, Now we need to consider, here a new concept will come, that is relative velocity. So relative velocity, you must have studied in your physics. So relative velocity is nothing but, it's very simple. When two bodies are moving with the same directions, now you see both are moving in the same directions. You can consider this is, suppose x direction movement is there, or the direction of z. Okay, so when the two bodies are moving in the same directions, then we need to identify the relative velocity. Actually, now we need to consider the jet of the fluid which is striking this jet, which is striking this plate, is not the velocity of the jet. That we need to consider absolute velocity. Okay, so that we need to consider. One is absolute velocity. Okay, and absolute velocity, and we need to consider this is which one, the jet of the velocity, what I told you, this is v, and the another one velocity, the velocity of the plate, that which is moving here. So the relative velocity, what we can write actually, so this is nothing but the absolute velocity, this is absolute velocity v, and the velocity of the plate, that is u. So this is actually the relative velocity of the jet, relative velocity of the jet with respect to plate, with respect to plate. So relative velocity will be calculated when comparing of two bodies or two objects. We cannot consider a single body's relative velocity, because we are comparing two plates here. This is one plate, this is not two plate, two moving body you can consider. One is velocity of the jet, another one is the velocity of the plate. Similarly, if you compare like two vehicles are moving in same directions. Suppose one bike rider is moving in this direction, another one bike rider is also moving in this direction. So one suppose moving with a some velocity will be there, suppose 50 meter per second, some vehicle is moving, another one vehicle is moving suppose 30 meter per second. Then we can consider, we can calculate what is the relative velocity of one body. Okay, what is the relative velocity of one body which is having highest one. So the relative velocity of this body with compared to the another one body, that we need to consider. So this is suppose vehicle 1 and this is vehicle 2. So here we need to calculate the relative velocity of the vehicle 1. So with respect to vehicle 2. So how you can calculate? So velocity, relative velocity V are equal to, you can calculate V1 minus V2. So this will be here 20 meter per second. So relative velocity of this vehicle 1 is 20 meter per second. The same conditions or same concept applied here. So this is the relative velocity of the jet with respect to plate. So this is one equation you can consider. This is the important term in this concept. Remaining are very simple as what we have done previously. Same thing we need to follow here also. Now again we need to find out first one. Before going to calculate the force, let's find out the mass of the body. The mass of the body in the sense the mass of fluid or the mass of water. The mass of water striking the plate, which is the mass of water striking the plate per second. So this one also you can write this, we know that rho AV. So directly I'll write here, this is rho AV. So this one we know how to identify here, but here velocity actually we need to consider. Here the velocity we need to consider actually rho A, and this is V minus U. As I told you, the mass of the water striking the plate per second. So here we need to consider the relative velocity. Okay, not the absolute velocity. So the absolute relative velocity is V minus U. And this one how you got? We know previously, already I told you number of times. This is mass flow rate per second. This means mass per time. So mass per time we can write, this is mass plus we can write rho into volume. Okay, rho equal to mass by volume, so we can write rho into volume by time. Time is nothing but second. So velocity per time, this is velocity per time second, that is Q. Discharge we can write, so this is rho into Q. So Q plus we can write discharge equal to, also we can write rho into area into velocity, because this one A into V. Okay, so that's a rho AV, mass of water striking per second. So this is equation 2. Now we can calculate the force exerted by the jet. So the force exerted by the jet on the moving plate in the direction of jet. This is in the direction of jet we need to consider. So this is nothing but, we know that This one also you can write the force equal to rate of change of momentum, also you can do it, and in terms of this one also you can do it, like m into here, this is nothing but mass of water striking this one, mass flow rate we can consider, and into initial velocity which is water striking, that is we can consider v1 minus this is v2, and here I'll write v1 equal to initial, this is initial velocity with which water strikes, that is nothing but the relative velocity. Okay, and similarly the v2, this is final velocity after striking, this is final velocity. So final velocity actually in the direction of the jet, if you see, the final velocity in this plate will be nothing but it will be 0. Okay, because here we got the relative velocity v minus u, and the same relative velocity goes out from this plate. Okay, but what about this impact at the final velocity at this plate? That will be 0 here actually, and this will be our relative velocity what it strikes the plate. So very simple, we can write here. So this is Fx equal to the mass flow rate. You can write this is what we got here, this one rho, this is nothing but rho a, and this is v minus u bracket start, or this one you can give normal bracket, then here square bracket we can give, because inside again one more velocity v1 is there, that is relative velocity v minus u, and the final velocity after striking on the plate, that will be 0. So this 0 is final velocity in the direction of jet is 0. Okay, in the direction of jet, because the water is moving out from here, so in this direction that is 0. And finally if you solve it, we will get it here, that is rho a v minus u, the square will get, this is the square, and this is our equation number 3. Okay, this is our requirement. Now one more thing I'll show you here. Yeah, this is our requirement as for the derivations, the force exerted by the jet of water in the direction of jet on the flat plate. So now you can see there is some work done happened here. As I told you, there is some work done happened done by the jet on the plate, because the plate is moved. You can see the plate is moved with the distance, some x distance moved. Okay, for the stationary condition, the plate is not moved that time because it was fixed. So here there is a movement of that plate was there. So we can calculate the work done. We can calculate the work done per second. Work done per second by the work done by what? Work done per second by the jet on the plate, we can say on the plate. So this one is nothing but we can write, this is, we know the formula, force into distance, how much distance moved. So distance moved is x, and per second is nothing but we can write, per second is nothing but time. So distance per time we can write, this is velocity. So that is nothing but force into velocity. So velocity is what here? We need to consider the velocity at what velocity is moved here. So that is u. At what velocity this is moved, that is nothing but u. And here what is the force we got here previously? The same thing we need to write, that is work done equal to, we can write this is Fx, this one Fx. So we can write here directly rho a, and this is v minus u square into u. Okay, this is our final equation of work done. Just to multiply force into velocity. So this is equation number 4. Okay, this is the work done, and the unit will be for this, we can write in watt or Newton meter per second also you can write. Okay, because this is Newton and this is meter per second, force into velocity. So this is nothing but work done per second by the jet on the plate. I hope you understand this derivations. This is simple, only you need to, a new concept came here, this is relative velocity, that is only the one. Remaining are very simple, what we have done previously, the same thing I have done here. So still if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you.